Swapnil Bhartiya here with Rob Hirschfeld, CEO and co-founder of RackN. Today we are going to talk about how to improve your Terraform hygiene at a scale. So Rob, let's talk about Terraform. What kind of trends are you seeing for Terraform orchestration layer?
Thank you. It's a pleasure to be here. So most people are familiar with Terraform at this point. It's really a dominant infrastructure as code tool that's used to set up and tear down all types of infrastructure. But what we see is more and more people use it. They're looking for ways to make it orchestrated. So not just use Terraform, but to run Terraform as not as a service necessarily, but allow it to be run not as a desktop tool. Move it into cloud or controlled surfaces, hook it together with other components in your infrastructure, really go from it being a tool to being part of an infrastructure pipeline. And we see that as a real big jump in how people are talking about and using Terraform.
With this jump in use of Terraform, what are some of the most notable challenges users are facing?
The challenge with Terraform as a tool is that it was designed to make it really easy to work from a command line desktop, but as an enterprise where you're trying to coordinate operations around a lot of different people or a lot of different teams, Terraform doesn't do those things as well. So what we find is people who are used to running Terraform just on a desktop, they don't understand how to put together work with other people. So they'll do it, that's something that works for themselves, but it might not translate well into other people in their team or even reuse by other teams. So a lot of our customers are looking at platform teams or SRE teams or some centralized DevOps infrastructure work. And it's very hard to take Terraform and use it in those more centralized teams. And that's a really important thing for people to understand, because what we don't want to have happen is everybody building their own infrastructure as code patterns and templates and things like that. When you do that, it can be very difficult for somebody else to understand the work you've done. And that's one of the challenges that we see with our customers, is they're being very productive with Terraform, but they're not being very productive as teams using Terraform.
You mentioned teams. There are teams, not a team, and even within teams, there are members of those teams. What about credentials? What challenges are there to manage credentials, and how can it be improved?
Credential management is absolutely critical, right? You do not want, in any case, to have one set of credentials running around doing all the work. And with Terraform type operations, you actually need permissions to build, destroy, create, connect things in the cloud. So what we don't want people to do is have one set of credentials that everybody uses to do that. We actually should have team, or even better, individual credentials used for those operations. The challenge becomes if you build a plan for Terraform, it's basically the template that you feed into the tool, those require credentials. Either they're coming from your local machine or they're embedded in the file. And if those credentials are embedded, then you're not using the runner's credentials. And you can actually have the risk that somebody could get a hold of critical cloud credentials and then pass them around or strip them out of that Terraform file or use them in ways that you didn't intend them to be used. So it's very important that as you build any infrastructure as code tooling, Terraform and others, that the credentials are not part of those files. It actually has to be injected in or stored with an external secrets manager, or like what we do at Digital Rebar, actually dynamically injected at the time you need it and then thrown away so that there's no record of what those credentials were in log files or in the history. So it is absolutely essential that you consider the permissions being given to any infrastructure as code tooling as you build and manage that tooling.
Can you help folks understand the difference between IAM, things like authentications versus authorization, and how does Digital Rebar help with that?
So it is a very important distinction to understand that when you're dealing with a credential, that credential has to have permissions to touch all of the things in the infrastructure that need to be set up. And in a lot of cases, in a lot of companies, they don't want to give out very broad, generous tokens. So you really want to be able to control that access system. And one of the challenges with something like Terraform is that it can require you to have very broad access to the infrastructure in order for you to perform basic operations. The way we deal with that is we actually separate the action of calling the Terraform template from building clusters or running machines. So Digital Rebar actually allows you to abstract those functions so that you don't have to give out credentials to all of the teams. Because in some cases, you just end up building very wide credential sets, and you don't want to hand those out. And so what we've done by creating a resource broker abstraction is that resource broker abstraction can be managed and controlled. And then the cloud credentials that actually have access to do all the building through Terraform can be much more restrictive in use. And that's a really good pattern for sort of delegated control. And one of the things that you need to be thinking about as you use a tool like Terraform is who should be calling all these Terraform scripts. And if you're just handing them out and letting people do it themselves, then everybody has to have access to it. If you can put it behind an abstraction boundary, then you can actually control who runs the Terraform scripts or how they're run or how they're invoked and get a lot more control back in your organization.
Let's talk about reusability of code. How does Digital Rebar help with it to reuse the code, to share it, and of course, collaborate on it?
As we build Digital Rebar, we really look at it as a programming platform for infrastructure and automation. So reusability and reuse and modularity are top of mind for us. And so it really is important that when you look at a code platform, it's not just that you can use things from the community. So for example, Terraform's really good about having, say, an Ansible or an Amazon or a Google or a Microsoft library that you can leverage against their APIs. But once you've built that plan, the components of that plan can be very hard to reuse or improve or change or fix. And so what we really see as a challenge here is that you don't want to have everybody in your team building custom plans. The ideal pattern would be that the things that are unique for a team or an individual's needs, usually a team needs, can be encapsulated in a very small part of a much broader template or plan. And that way, your operations teams or your cloud professionals can actually evaluate the overall syntax of everything that gets built and say that it's conforming and following best practices. In a lot of cases, we're able to bring best practices in, and companies don't even have to invent them. But if they have teams that are skilled in this, they can define best practices. And then you want everybody using pretty much the same plan so that you're not creating sort of custom generations. If people do it differently, then your security team or your platform team is going to have a lot of trouble knowing what was built, or knowing that it was built securely, or confirming that it had all the right things checked to it. So we really want, even in the context of a big plan, most of that should be standardized and come out of the teams who know the infrastructure best and can follow the standards that the enterprise sets. And then if there needs additional complexities or changes, those should be relatively small snippets of templates injected back into that plan, which is exactly how Digital Rebar approaches it. Because that type of reusability really translates into better security, less toil for everybody, and most critically, and I really don't want to overlook this, it allows teams to work together. Right? It's really frustrating for individual teams if the people who understand the platform or the cloud, if they have trouble helping you, then you're wasting time. And if they bring you a problem and it takes them a couple of days to figure out what you've done, then everybody's wasted a lot of time. We're trying to really streamline this to improve security, but also reduce toil.
Can you share some insights on managing Terraform's state files?
If you've been using Terraform for any length of time, you should be familiar with the state file challenge. So what Terraform does is Terraform, because it was designed as a client tool, stores its state as a static file. And every time it runs, it updates that state. There are tools that allow you to centrally manage that state file, but it's fundamentally still a file. And what we see happen is if that file gets changed or fixed, or somebody runs Terraform but doesn't update that file correctly, then the infrastructure that's deployed and that file don't match anymore. And if they don't match, Terraform will either give up, which is a challenge, or it will try to fix the infrastructure to match what it thinks it should be. And that might involve deleting, removing machines, rebooting them, rebuilding them. It can be very, very disruptive to have state mismatches in Terraform, because Terraform assumes that what's in that state file is the truth. And The challenge with that and managing that is that if you're not very careful in how those files get managed, built, and then stored, you can find that your infrastructure is unstable and very hard to repeat, very hard to figure out what's going on. What we've done with Digital Rebar is we've made that process of storing and tracking those files much easier. So it's an inherent part of the processes that we run. But even more than that, what we do is we'll build a map of the resources that are consumed outside of Terraform. And actually, that's part of the key infrastructure pipeline strategy, is that once Terraform has built resources, they have their own life cycles outside of Terraform and can continue doing configuration, automation, management, tracking actions. And so there's a couple of layers in managing these files and making them successful. One is storing them well and making that an automated part of the process, but also not relying on those files as the only source of truth that you have, and being able to work with systems outside of Terraform. And so sort of that combination of approaches is really what makes something work very, very well from a Terraform perspective. I always say this, and that's an important thing. Tools are great. So, Terraform is a remarkably powerful tool, but using it within its strengths is the way to keep yourself sane and healthy. If you start trying to take these tools, any tool, and use it in ways that it wasn't designed to use, you're going to run into the sharp edges really quickly.
Cloud waste is a real concern due to orphaned resources. How does Digital Rebar help cut down on cloud cost?
So by managing state files better, you can definitely help avoid orphaning resources to an extent. But one of the things to do is to remember that any tool that you're using, you can get drift from how that tool understands the universe and what's actually in the universe. That would create an orphaned resource. So if you applied a Terraform file that from an earlier generation, it might not be aware that it had provisioned resources. You could literally have resources floating that you weren't aware of existing in that system. And so part of the way to think about this and be aware of it is that you want to have entries in a separate accounting system outside of your provisioning infrastructure. And that is really helpful when you're using Digital Rebar. We're very careful to track that and do some basic cost estimation so you know if you're leaking costs. But then also, being able to go back and do an audit and understand where the inventory is and check and confirm. Being able to make that easy is a really important part of thinking through how these systems operate.
I want to talk about Digital Rebar's role in helping teams collaborate across organizations.
So I'm glad you're bringing that up, because infrastructure as code, we get excited about the tools, right? The files and all these bits and pieces. But you're right, collaboration is really what's at the center of this. When we talk about infrastructure as code, it really is about how do you make automation, software, and infrastructure more developer-like. And all of the developer tools that we're used to, like GitLab and Git, the tooling, automation libraries, packages, open source, a lot of it is actually about collaboration. How do we increase the reuse so that the modulars are reusable, right? Nobody would write an HTTP server in a language anymore. You're going to pull in a module. And that is exactly the goal for infrastructure as code, and what people need to be thinking of when they look at their teams, their tools, the platforms that are assigned here, is how are they improving my collaboration across the organization? Because if you can find, and we believe Digital Rebar does this very, very well, if you have a platform that allows your teams to work together and coordinate work better, then you have actually improved your infrastructure as code outcomes. If you have a platform that allows you to reuse automation from outside your organization or across teams, then you're going to improve your outcomes. And we see this dramatically with customers. Our customers are able to replicate success site to site to site, or team to team to team. And in a lot of cases, they haven't even had to write that automation. They can just bring in libraries and extend the libraries that have already been proven by other customers. And so we see this dramatic collaboration effect of using infrastructure as code in a very cooperative way. And it really is transformative.
Rob, thank you so much for taking time out today, and of course talk about, once again, an interesting topic and great insights as usual, and I look forward to our next discussion. Thank you.
So thank you.